Hi everyone, welcome back to Introduction to Artificial Intelligence and Machine Learning. In the previous session, we give an overview and introduction on machine learning. In this session, we will try to give an overview on the general machine learning workflows. Machine learning workflows defines which phases are implemented during a machine learning project. The typical phases include data collection, data preprocessing, building datasets, model training and refinement, evaluation, and deployment to production. You can automate some aspect of the machine learning operation workflow, such as model and feature selection phases, but not all. While these steps are generally accepted as a standard, when creating a machine learning workflow, you first need to define the project and then find an approach that works. Don't try to fit the model into a rigid workflow. Rather, build a flexible workflow that allows you to start small and scale up to a production-grade solution. Machine learning workflows define the step initiated during a particular machine learning implementation. Machine learning workflows vary by project, but 4 basic phases are typically included. That is, get data, analyze data, develop machine learning model, and deploy machine learning model. When defining the workflow for the machine learning project, there is always one step that we should do before all these technical steps. That is to define the project goals before starting to ensure our models add value to a process rather than redundancy, such as what is our current process, what do we want to predict, and what are our data sources. And then we can start to research and experiment in order to build a full-scale solutions. In each step, we try to outline some important things that we should do. When we try to get data, we will acquire and analyze real-world data. We can collect data from open source database, and we can even use synthesized data from simulation. And some common source of data are like sensors, files, and databases. During analyze data stage, we will involve data preprocessing, data wrangling, feature engineering, and machine learning, such as exploratory data analysis, data preprocessing, and to develop some domain-specific algorithms. During machine learning development stage, we will develop either machine learning or deep learning algorithms, and we will also evaluate the machine learning model and see what is the performance. Finally, we will deploy the machine learning model for production usage, and we will also monitor the long-term model performance. Some deployment techniques such as we can deploy the model into desktop apps, into enterprise system, or even into embedded devices. Now let's try to focus step by step. Talking about the first step, when we start the machine learning project, following the whole workflow, gathering data is always one of the most important stages. During data collection, you are defining the potential usefulness and accuracy of your project with the quality of the data you collect. Data gathering is the first step of the machine learning life cycle. The goal of this step is to identify and obtain all data-related problems. In this step, we need to identify the different data sources, as data can be collected from various sources such as files, database, internet, and mobile devices. It is one of the most important steps of the life cycle. The quantities and qualities of the collected data will determine the efficiency of the project. The more will be the data, the more accurate will be the prediction. By performing the above tasks, we get a coherent set of data, and we call it data sets. It will be used in further steps. So actually, what is a data set? A tabular data set can be understood as a database table or matrix, where each column corresponds to a particular variable, and each row corresponds to the fields of the dataset. The most supported file type for a tabular dataset is comma-separated file, or CSV. But to store a tree-like data, we can use the JSON file more efficiently. There are different types of data in a dataset. We have numerical data, such as age, salary, house price, etc. We can also have categorical data, such as yes or no, country names, and ordinal data. These data are similar to categorical data, but can be measured on the basis of comparison. Please take note, a real-world dataset is of huge size, which is difficult to manage and process at the initial stage. Therefore, to prepare machine learning algorithms, we can use any dummy datasets or simulated datasets. After collecting the data, we need to prepare it for further steps. Data preparation is a step where we put our data into a suitable place and prepare it to use in our machine learning training. In this step, firstly, we put all the data together and then randomize the ordering of data. This step can be further divided into two processes. Data exploration is used to understand the nature of data that we have to work with. We need to understand the characteristics, formats, and qualities of data. A better understanding of data leads to an effective outcome. In this, we find correlation, general trends, and outliers. Then the next step is preprocessing for its analysis. Preprocessing involves cleaning, verifying, and formatting data into a usable dataset. If you are collecting data from a single source, this may be a relatively straightforward process. However, if you are aggregating several sources, you need to make sure that data format match, that data is equally reliable, and remove any potential duplicates. Data wrangling is the process of cleaning and converting raw data into a usable format. It is the process of cleaning the data, selecting the variable to use, and transforming the data in a proper format to make it more suitable for analysis in the next step. It is one of the most important steps of the complete process. Cleaning of data is required to address the quality issues. It is not necessary that data we have collected is always of our use, as some of the data may not be so useful. In real-world applications, collected data may have various issues, including missing values, duplicate data, invalid data, and noise. So, we use various filtering techniques to clean the data. It is mandatory to detect and remove the above issues because it can negatively affect the qualities of the outcome. Now, the clean and prepare data is passed on to the analysis step. This step involves selection of modeling techniques, building machine learning models, and evaluate the results. The aim of this step is to build a machine learning model to analyze the data using various analytical techniques and review the outcome. It starts with the determination of the step of the problems, where we select the machine learning techniques such as classification, regression, clustering analysis, association, etc. Then build a model using the clean and prepared data, and evaluate the model performance. Once training is complete, you can then refine the model using your validation datasets. This may involve modifying or discarding variables, and includes a process of tweaking model-specific settings, so-called hyperparameters, until an acceptable accuracy level is reached. Finally, after an acceptable set of hyperparameters is found and your model accuracy is optimized, you can test your model. Testing uses your test datasets and is meant to verify that your model are using accurate features. Based on the feedback you receive, you may return to training the model to improve accuracy, adjust output settings, or deploy the model as needed. The last step of machine learning lifecycle is deployment, where we will deploy our machine learning model in the real-world system. If the above prepared model is producing an accurate result as per our requirement with acceptable speed, then we can deploy the machine learning model in the real system. But before deploying the project, we will check whether it is improving its performance using available data or not. The deployment phase is similar to making the final report for the project. Most data science projects deploy machine learning models as an on-demand prediction service or in batch prediction mode. Some random applications deploy embedded models in edge and mobile devices. Training machine learning model is only one aspect of a data science project. We still have to put a lot of effort to deploy them in a real production environment. Please take note, this is not the end of story. We still have to monitor the machine learning model by constantly evaluating the model performance using real-world data. If the model performance degrades or is not up to the standard, we may have to restart the whole process again by retraining the model using new and updated data.